Hello everyone, welcome to Simulaciones Finitas, your engineering YouTube channel where we do a lot of simulation. In today's video, I'm going to show you three applications of FEA in the industry. The first one is related to composites in pressure vessels. Secondly, we will see an overview on repairs in storage tanks. For example, here we have a lab patch repair in a corroded area. And finally, we will see how to incorporate actual measurements from inspection, like this, into your FEA model in order to see if it passed the elastic plastic analysis. I hope you enjoyed it, and let's get started. In our first example, we will work with the same geometry used in this publication from IMECE 2017, where they work with a pressure vessel. Here we have it, the geometry. It has a radius of 1 meter. It has two hemispherical heads, as we can see it here. In this publication, they did a comparison between two materials. The first one is related to a composite using an aluminum as a liner. It is a ½ inch of thickness, and then it has a composite overwrap of approximately a ¼ inch. So I'm going to show you the solution for the vessel using a stainless steel of 3/4 inch of thickness. Here we can see it, and the material we are using is stainless steel. This is a linear elastic simulation. Here we have the pressure, which is around 500 psi, and we are having a fixed support here in the joint between the shell and the head. Here we have the solution for the total deformation, equivalent stress, bending, and membrane stress, right? So we want to compare not only the stresses that we have in the vessel, but also the weight, the total weight of the vessel. Here, for example, it has a weight of around 10,000 pounds. If we do a simple parameterization, for example, using some parameters, here we can see how the change in thickness increases the stresses. For example, here the equivalent stress. If we work with 3/4 inch, the stresses, for example, the equivalent and the bending, are of these values, right? Now let's see how it behaves in a composite pressure vessel. Okay, before giving further details of the results of the simulation for the composite pressure vessel, we need to define first some material properties. Here we have the fabric for the epoxy glass and the fabric for the aluminum, which is the liner for a composite pressure vessel. For the epoxy glass, we need to define some stack-up properties. These stack-up properties allow us to define, for example, the orientation of different fabrics. When we define this, we can use laminates at the end to define the total thickness of our composite, as you can see it here. We have more or less a ¼ inch of composite. So once we define this in our simulation, we can see here now how is here for example we have the aluminum. This is the cap properties, and we use the same conditions: internal pressure of 500 psi, fixed support, and we have the equivalent stress and total deformation. If we compare the results of the stress distribution for the stainless steel pressure vessel, it has a single value. Here, because we have a different configuration, we have different stresses through the thickness. But more importantly is to consider the total weight of this pressure vessel. So it's more or less 200 pounds compared to this pressure vessel of around 10,000 pounds. So this is one of the advantages of choosing composites in the design, in your design. Okay, so finally I want to show you the failure criteria of SAIWU that is used for composites. In other words, this failure criteria means if you reach 1, then your composite fails. In this case, we have a maximum value of 0.91 here. So it means we are okay. At the right side, we have a table for the stainless steel pressure vessel, where we have different thicknesses for the cap and the shell. And here we have the total weight of this pressure vessel. So we have the maximum stress values for bending, remember? And those values are compared against the allowable maximum stress. So that's all I wanted to show you, some benefits of using composites and some benefits of using FTA in the design of pressure vessels. We are finishing the second part of this video, so I hope you like it and subscribe. So have a good day. Take care of yourself. Bye.